Hello everyone. In this video lecture, I am going to explain you about the concept of destination sequenced distance vector routing protocol, shortly named as DSDV algorithm. So, what does this literally mean? The destination sequenced distance vector is a hop-by-hop vector routing protocol that requires each node to periodically broadcast routing updates. So, it comes under the category of proactive routing algorithm or table driven routing algorithm. So, in this destination sequence distance vector, each node will have the entire information about route in the form of routing table, where the routing table contains the attributes of node, destination, next hop, distance, and sequence number. So, with the help of this table, all the information can be gathered in the form of table-like structure. So, let me explain this with the help of a small example. Here, you can see the small network which has three nodes, that is X, Y and Z. The very first step is to draw a separate tables for all the nodes X, Y and Z along with the distance and the sequence number. Here, I have given the data for the individual nodes X, Y and Z, where it contains the information of this source node, destination node, next hop, followed by a cost, which is nothing but your distance, and then the sequence number. In the first case, I am keeping my source node as X. So this source node has to travel to all the different nodes which is connected to it. Here I am considering first I am considering the source is traveling from X to the destination X. So here my source node X is traveling to the destination X. Here I don't find any next hop to the X. So, the cost of the link is 0 because there is no connection from the source X to X. So, I am mentioning the cost is as 0. And the sequence number may be any random number. So, I have written as 100. Here, the next connection is from my source X to the destination Y. Source X to the destination Y. Here, the distance from X to Y is the value 1, which is nothing but my hop. Count of hop is nothing but the value 1. That will be represented as my cost. The cost of the source X to Y is 1. So then what do you mean by the next hop? Next hop is nothing but what is the node which is present to next to my source node. So as I am considering this X as my source node, the node which is present next to my source node is nothing but Y. So I have mentioned the next hop as Y. Okay, do you understand? In the, and my sequence number is nothing but any random numbers. I have mentioned it as 200-Y. So in my next case, my source will be X and my destination will be Z. So my source to destination should travel through the node Y. Okay. So my present source node is X, the next hop will be Y, and finally it reaches my destination node Z. So the total hop link cost is nothing but 1 plus 1. So the total count will be 2. So the cost of the link from the source X to the destination Z is nothing but 2. Okay. So the sequence number will be any random number. So I have mentioned it as 300-Z. Okay. In the same way, we will be considering the source node as Y. In this case, we are having three possible destinations. One is the source Y has to travel to the destination X, and the source Y has to travel to the destination Z, and then Y to Y itself. So, three possible connections we are going to update in the form of table-like structure. Okay. First case, the source Y has to travel to the destination X. Okay. First case, the source has to travel to the destination X. So, the Y is my source node and it is traveling to my destination X, which has a distance of 1. So I can update the cost value as 1 in the table. Similarly, the next hop, since this is my source node, the next hop which is present to this source node will be X. So my next hop will be X. And my sequence number may be any random number, so I have mentioned as 100-X. Okay, the next connection is getting established from the source to destination, y to y itself. So there is no next hop. Since there is no link connection between y to y, the cost of my connection is 0. So the cost will be written it as 0. And the sequence number may be any random number. So we have mentioned as 200-y. The next connection, y to z. The source is my y and the destination is my z. So the next hop will be not y, the next hop will be z. Okay. The next hop will be z. The source will be y, the destination will be z. The next hop is also z and the connection is getting established from y to z. The link cost is nothing but the value 1. So we can update the cost as value 1 and the sequence number may be any random number. Okay. Now, in the same manner, we have to update the routing table for the source node Z. So, imagine that network which we have seen in the previous slide. The where network comprises of 3 nodes X, Y and Z. X is connected to Y and Y is connected to Z. The link of that distance is nothing but 1 each, right? Do you remember that? So, this is the network structure we have seen in the previous slide, right? So we'll be having we have 3 nodes X, Y, Z, which is interconnected with the link cost of 1 each. Okay, as discussed earlier for the 2 nodes we have discussed now for X and Y. Similarly, we have to make a routing table for the source node Z to other destination nodes X, Y, and Z. Here in the first case, my source node will be Z. So my Z has to travel to the destination X. Okay, I have to travel from the source Z to my destination X. So this connection will happen only through the intermediate node Y. Okay, my path has to travel from Z to Y and then only Y to X. So my connection from source Z to destination X will be get completed. So in this table, I have to update the information as my source node as Z, my destination as X, and the next hop. The next hop is nothing but the node which is present next to my source node. Here, since my Z is my source node, the next node which is present to it is Y. So in the routing table, I can update the information as Y. Okay. In the next case, my source node is Z and my destination is Y. Okay, my source node is Z and my destination is Y. Obviously, my next hop will also Y. Okay, the link cost will be 1. In the previous case, I have failed to explain the cost of link. Since my connection is from Z to X, there has a 2 link, right? From Z to Y you have 1 link and X to Y you will be having 1 link. So the cost of each link is 1. So 1 plus 1. So my cost will be 2. Okay. Similarly, in the second case, you have to travel from the source node Z to the destination node Y. So source node Z to the destination node Y. The next hop will be Y. So the link which is the cost of the link which helps to connect from your source Z to Y is nothing but 1. So the cost of the link is 1. And for all the combinations, the sequence number may be any random number. Okay. So we have mentioned as 100, 200 and 300. Okay. Clear? So in this way, destination sequence distance vector routing algorithm will update the information in the form of this given table-like structure. Okay. So in this way, DSDV algorithm updates all the information in the form of table-like structure, which has the data of your source node, destination node, next hop, cost, and the sequence number. So let us consider another case. For example, we have seen the network which has three nodes, right? X, Y and Z. If I want to add an extra node called A, okay? So this information has to update in the routing table. This updation will be done in the form of two ways. One is full dump. Another one is incremental update. Okay, one is full dump, another one is incremental update. Full dump is nothing but the information, the newly added information will be completely dumped into the routing table, which is nothing but all the information right from the beginning to end will be updated into the routing table. Whereas your incremental update is nothing but what the updation has happened, only that particular information will be updated to the routing table. So in this way all the functionalities will be happen, and in the same way all the informations will be broadcasted to all the neighboring nodes which is presented to it. In the next case, if you want to remove any node which is present in the network, for example, we have seen that three nodes are getting connected, right? X, Y and Z. For if we removing the node Z, means the left out node will be only X and Y. So what happened in the routing table is the distance for the value node Z will be tends to infinity. So since there is no connection path is getting established from all the nodes present in it, so the distance will be turned to infinity. So we cannot, it means that there is no way to travel to that particular node. In this way all the updations will be happening there. Okay. So as I explained you earlier, the updation will be happen in the form of two categories. One is full dump and another one is incremental update. Full dump is nothing but the entire information will be updated into the routing table right from the beginning. Whereas your incremental update is nothing but only the updation of that particular node will be happen in that moment. I hope this video gives a better understanding about this distance vector routing algorithm. So, thank you for watching.